Hello everyone, so today we are going to do Leetcode daily challenge, divide two integers. So in this question, we are given the two numbers, basically two integers, and what they mean by integer is that it could go to negative space and positive space as well as and even it could be zero also. So thus they have used the term integers here. So now, what we are required to do in this question is we are required to return the quotient after dividing dividend by divisor. But the conditions which are here is that here without we using the multiplication, division or mod operator, we are required to do this operation. So when these conditions are being there, so we are required to think in another terms. Basically, if we go towards the memories of our childhood, then we could think about that how we used to do division, right? We did division and multiplication, division and mod operations, but there were some other methods also which gave us the core of divisions, right? How this 10 could come up with the help of 3. How we can do that? Basically, we do division, then how we do it? We check 3's table and then simply divide that nearest number and get that remainder, right? So how that all thing comes up? So in that context, if we think that what modification we could do to this particular divisor, basically this 3, so that we get a particular non-negative remainder and get our quotient as our answer. So we are required to think in that particular direction. Okay. So now before moving ahead, let us check that what are the constraints of this question so that we could know more better about the same. So as I mentioned that they have mentioned it is to be integer, so it will take negative also, and both dividend and divisor, both of them could be negative and both of them could be positive also, and either of them could be negative and positive, and divisor is not equal to 0. This they have explicitly mentioned that divisor can't be 0, but dividend could be 0. That is the case here. And yeah, divisor can't be 0 because of the fact if we divide anything by 0, then there is that if there is a means 0 division is not allowed, right? So in that context they have given. Now after checking these constraints, now we can think in that direction which I was saying. So how we can modify our divisor, that we need to think, right? So if we go to the table of 3 and check what is the nearest of this dividend, right? So in that context we could simply get our quotient, right? That is the thing which we are required to do here. Now we can't write the table here, right? So how we need to proceed with the same? So we can do by simply using a for loop and get all the possible numbers, and simply means basically 3 multiplied by 1 means 3, then 3 2s are 6, then 3 3s are 9, right? Like this we would be getting, and what we need to do with this is we need to subtract all this from the dividend. Means each time we'll do 10 minus 3, then what we will get 7, right? Then 7 minus 6, then what we will get directly 1, right? But at this particular point our divisor, that is a 3, right? This 3, and moreover one more thing is there, like continuously we subtract it, then we also need to keep a check on the remainder also. Now this is the remainder here, and then 1 minus 9, right? So it would be a negative number, right? But still our answer is 3 here. So in that context we are required, because the thing is that the strategy is this only, but we need to think in some other direction, because okay, now like this only we would be going ahead. 1 and then 2 and then 3 would be our quotient, right? Now comes the part of this negative thing. Okay, we'll take that how we are required to do. Okay, So 10 minus 3, 7 would be there as a remainder, and we are required to continuously continuously subtract from it. And yeah, it is true that whenever we go ahead, as this particular thing will increase only. Okay, so like this, we need to do modification, some one or other thing. Okay, so the actually thing which is here is because the thing is whenever we do it like this, means multiplied, then surely it will become greater than 9. So the thing is we don't need to divide our dividend with whatsoever we get as our multiples. Basically, what we are required to do is, means we won't be doing this. We would be simply doing this thing. Means 10 is our dividend, so we'll subtract from it and we'll now get 7, right? Then we'll subtract 3 from it, not this 6. And then we will get our 4, and then when we'll subtract, this will be our every time a new dividend. This will be the thing, and we'll always subtract this divisor. And each time when we do this, we will be adding up all these things, means simply incrementing, not adding. These are the questions which we are having, right? So just what I'm telling here is that how we are required to modify that thing which we used to do in our junior classes. And then 4 minus 3, it would be 1, right? It is still greater than 0, right? But if we go further, right? Now 4, 3, 4 is 12, but now if we do, now we are having 1, and 1 minus 3 would be negative, right? So this we'll discard this particular step, we'll go till this step. So what we are doing here is, means, see, here also we will be getting a quotient, basically our answer, that is 3. But the thing which we are required to do is, because when we used to divide, what we used to do, we simply subtract whatsoever thing which we were having from this particular dividend and get our answer, right? But if we split this particular thing in steps, then in actual the things are like this. Means basically each time we are subtracting our divisors from the new dividend which we get after subtraction at each step. This is what we are doing. So this is like simplest thing which we can do, but there are edge cases for the same, because of the fact we are having a negative space also and positive space also, right? So in that context, we are required to do basically convert both of dividend and divisors as negative numbers. First thing is we can do this, means convert both as negative, so that we get a higher space for basically a subtraction and so on, so that there is no overflow. Or second thing we can do is get the absolute of both of them, absolute of this dividend and absolute of divisor, both of them, right? But we need to convert them into log. So these are the two options which we could use to increase the space and to increase the space of our calculation, right? Because there is a condition of that integer overflow which we will encounter in this solution. So in that context I am saying. But the thing is that while we would be doing this in n steps, where n simply means this particular question which we would be getting, or at worst scenario it could be a scene that it could be equal to dividend itself. That worst scenario will be when divisor is 1, right? So in that context it could go till dividend, means whatsoever our dividend would be, so it will act as our n. So in that context the time complexity would be order of n and the space complexity is order of 1, because we are not using any extra space. So this could be something like that. It could be a costly operation to us because it is going till order of n. We could further optimize this. If we think in terms of power, then we could simply optimize this. And if we think in context of power of 2 basically, because in numbers we could play with the bits, right? So if we go in that context, then we could simply reduce our time complexity to log n. Although this time complexity could work because it's 2 raised to the power 31, but still it is much costlier because it is 2 raised to the power 31. So that's why it is costlier for us. So we are required to reduce it. So in that context, we could think in powers terms. So this was for the first method which we could use. Now let us go for our second method. So our first method was continuous subtraction, which we were doing till now. Basically the continuous subtraction, in which the thing was, it was about that we are continuously subtracting dividend from divisor until both of them remain greater than or equal to 0. This is what we are doing. And the further edge case here was, we are doing this and we are incrementing the quotient, which would be our answer. And edge case here is the integer overflow, which we need to handle basically. And how we were handling that integer overflow was, first method was that both negative, means convert both to negative. Our second method was to take log. So this was the thing which we were using for our first method. Now comes the part for our second method. So our second method would be that because we want to simply reduce the time complexity, right? So we'll multiply our divisor with power of 2 and will subtract from the dividend until this condition is satisfied, which we were having this earlier also. So this is our method 2. And here the time complexity would be log n and space complexity would be order of 1. This thing I would be doing without bit manipulation in naive method only. The way we used to do. So the context would be something like this. Let me show you this. So here the thing would be that whatever dividend we would be having, it will remain as it is, but we will manipulate our divisor. Each time we'll multiply it by 2, right? And then at next step we'll simply do dividend minus divisor, and it will be our new divisor every time. And then whatever we get our answer, it will be our new dividend. This is what we would be doing, and in this whole process we'll increment our quotient. And here again the edge case would be of our integer overflow, that we need to keep a check. That would be our edge case. For that, first method, either convert both to negative space, convert both to negative, or use long. So this is the thing which we could use. And one more edge case is there basically, and that edge case was in previous one also, when our dividend is equals to, this was the first edge case and this is our second edge case. When dividend equals to int max, not int max but int min, and our divisor is equals to -1, then we are required to return int max. Because both are negative only, so we are required to return a positive number, right? And because it is int min, so it could go, it will go to the maximum possible limit of integer. So in that context, we are required to return int max. So these are the two edge cases which we need to handle in this question also, in this approach also. But the thing would be that here the we are simply multiplying by 2. Earlier what we were doing was, we were simply doing step by step. So that's why it was taking us time complexity is order of n. But here the time complexity would be order of log n. Why order of log n? See, I could give you the context of binary tree also. See, when binary tree is there, then what we do means first node is there, then when we multiply by 2, then it divides into 2, then further if we multiply by 2, then it divides itself into 2, and so on. And what is height of this particular? It is log n, right? So in that context, here comes this log n. Then we are simply multiplying by 2 at each step. So that's why we are reducing its time complexity to log n. So this is the context of time complexity for this question, and the space complexity would be order of 1 only. So this is how method 2 is there. Now let me show you the most optimized one. Even this is all the most optimized one, but this would be, which now I'm going to show the method 3. It is same as method 2 only, but more specifically I could say it as long division using base 2. It uses the previous method only, means method 2 only, and its time complexity is also log n, and the space complexity is order of 1. But here we would be using bit manipulation. So that would be the thing which we would be using. Actually, while doing this question at the start, when there was the constraints about these things, when there were constraints about the thing that we don't need to multiply, we don't need to divide, we don't need to do mod, right? So because of these things, what comes to our mind first is, we could either do subtract or we could do bit manipulation. These are the things which comes to the mind. So that's why this method just right. And then the other thing which was required to start with this method was the method of continuous subtraction. This is the most essential part which we are required to keep in mind, and only we could be able to strive this method. Because in the starting I was explaining that how we do division without dividing, multiplying or doing mod. We do it by subtraction, and that is the thing we would be using here. Means it is combination of first and second, but if we go back to our junior classes, we had done that long division method, right? So in that context it is here. Now how we would be doing this is, so the first thing which we will be doing here is, we need to check for the edge case. That would be here also. First edge case is that if our dividend is basically equals to int max, not int max but int min, and our divisor is equals to -1, then we are required to return int max. This is our first edge case. Now comes the second edge case, is our integer overflow. Here again integer overflow would be there, because the numbers could go till 2 raised to power 31, right? So in that context integer overflow would be there. So for avoiding that, we could either do that, make both dividend and divisor as negative, or we can use long data type. Okay, so these are the edge cases which we are required to handle here also. But now comes the main portion of this algorithm. So now the thing would be that we would be dividing at each step, multiplying by 2. So we need to manipulate that bit, right? So we need to keep check that our dividend is basically dividend minus divisor, basically both of them are greater than equal to 0. This is what we need to keep check, and until this particular condition remains true, we need to further do our things. Okay, so at each step what we would be doing is directly left shift our divisor. This is what we would be doing, and we'll keep a quotient and this particular would also be left shifted. But question at the starting would be equals to 1. That would be the thing. And when this thing would be there, so when we left shift it, so it will simply act as the count itself, and like this only we'll do these steps and we'll add up to our answer this particular question. And when we would be doing this, so in that context the thing would be at the end we would be equal, we would be returning this. And why we are doing this particular, because there could be a case that remainder is there just smaller than our given number, so in that context we are required to do this. So this is what we would be doing in this long division method. So let me walk you through our code so it could be much clearer, because I can't code everything here. So this is our that method in which we were basically this is that special condition, and here what we are doing is we are taking for avoiding the integer overflow, we are taking it as long, and then we'll take for the sign of our dividend and divisor. Why we are taking sign? Because we are taking long data type here for avoiding the integer overflow, right? So that's why we are required to take for the sign. And now we are doing this particular means that condition only when dividend is greater than equal to divisor, or we can say dividend minus divisor equals greater than equal to 0. So what we do is we take this long term where we will be having this divisor, because we are required to modify divisor at each step. So that's why we are taking this temp variable, and then this count is there, which is acting as a quotient, right? And then we will simply left shift our temp and also keep a check that it is less than equals to dividend, and then we'll do this and this. Why we are doing that I've already explained. And then we'll continuously subtract our temp from the dividend, and we'll add up count to our quotient, and at the end we will return sign into quotient, because there could be a scene where either of them could be negative, right? So that's why we are doing this. So this was all for this particular question. If you have any doubt, you could directly comment that down. So thank you.